Good day. This is Professor Russo. We're going to continue with our expansion of the ideas of factoring. We started section 6.3, which was talking about the factoring of quadratic expressions, where the a was equal to 1. Today, we're going to talk about the factoring of quadratic expressions where the a is not equal to 1. We have a lot of fancy names for that. Splitting the middles, ACB method. So again, first let's look at, if I gave you 4 terms, what if I said we're going to look at 4 terms and we want to factor? So look at the first example that Professor Cockerham came up with for our worksheets, right? And you see we have x squared plus 6x plus 5x plus 30. Okay. Now, what you see is also there is a grouping of the first 2 terms together and a grouping, I kind of like what his little clouds there, of the back 2 numbers together. So we can't factor. Let me just write it on the side. There's no way I can take an x out of everything, a greatest common factor. I'd be short over here. There's no x over here. I can't take a 5 out of everything. I can't take a 6 out of everything. So if I can't take a greatest common factor out of all 4, I try to kind of get away with what I can. So I'm going to group the first 2's together and then the back 2 together. And in those first 2, yes, I can factor a greatest common factor out of x. And when I do that, let's see what's left. Well, I'm taking an x out of x squared. That gives me an x. And I'm taking an x out of the 6x term. That leaves me a 6. Okay. And now, let's take that plus sign and not forget about it. If I look at the back 2 numbers, I can pull a 5 out. And I'll open up a parenthesis for the leftovers. And when I do that, I get x plus 6 in parentheses. So, I might say, okay, well, big deal, I'm all done. Well, just realize that I now have, with this process, created just 2 terms here. This whole first 2 is really now one expression because there's no plus sign between those guys. And over here, I have another 2 terms because there's no plus sign between those guys. I'm sorry, I said that wrong. I have actually 1 term because there's no addition or subtraction sign there, and there's only 1 term here. When I look at those 2 separate terms that I put in blue, okay, I have a parenthesis in the back term called x plus 6. I have a parenthesis in the front term called x plus 6. It is common to both. Therefore, it is also a greatest common factor that I can extract out. Because it's a greatest common factor, I can refactor it out and open up a parenthesis for the leftovers, just like we always do when we factor. And when we look at what's left over, we'll do those in green. Look what's left. The x and the plus 5. Now I've completely factored the 4 terms. Okay? And I did it by doing the greatest common factor wherever I could. Let's look at the next problem. Okay? You can see we again split them up for you using the green. Okay? That we got the first 2 grouped together. Right? And we got the back 2 grouped together. And I've already got the first step there. I can pull a 2 and an x out of everything. When I pull a 2 and an x out, I'm left with, well, I pulled a 2x out of the 2x. That leaves me an x plus, I pulled a 2 and an x out, a 4. And I'm going to factor the back 2. I can pull a 3 out. And lo and behold, I have an x plus 4. And so, like I did just a few seconds ago above, I can see that in that first term, I have an x plus 4, and in the back term, I have an x plus 4. It's in common. It's the greatest common factor, so I pull it out and list it once. And then I open up a parenthesis for what's left. Let's see what's left. 2x, don't forget to hook the plus sign in. 2x and plus 3. And I factor that. Okay. So we grouped the first two, we grouped the last two. Now, you notice that every time we do that, those parentheses are exactly the same, and we are allowed then to extract them out. Now, if you happen to factor and you find out your parentheses aren't the same, either the question wasn't meant to factor or you did something wrong. Now, if we're going to give them to you, we want you to know how to factor them. So if we give you a problem and you have differences in the parentheses, it's not like we made the problem bogus. It's like you actually made a mistake in your factoring. So let's go to question B. I'm going to pull out a 5 and an x. When I do that, I'm left with, open up the parenthesis, x minus 3. Bring that big plus sign down. We're going to see how important that is later. And factor out a 4. And lo and behold, one more time, yes, I get x minus 3. Because we're designing these problems so that that x minus 3 will come out in front as a new greatest common factor. And we open up our parentheses whenever we finish factoring for the leftovers, and the leftover is 5x plus 4, and we are done. If we look at question number C, we wrote a rule. If the first term in a group is negative, then factor out the negative with the GCF. So let's take a look at our first two. Right? We're grouping our first two together. We're going to group our back two together when we have 4 things. So on that first two, right, I can see that what comes out of there is a 3x. And I'm left with an x minus 2. Now, here's where that rule comes into play. Whoops. It says, if the first term in a group is negative, and you notice the 2 does have a negative sign with it. So we're going to take the 2, because 2 comes out of both 2 and 4, and also grab the negative along with it, open up a parenthesis. Now be careful, because we're really doing the distributive property backwards here. So when I pull a negative 2 out of the first term, nobody usually messes that up. And when I pull the 2 out of the 4, nobody ever messes that up. But here's what it's not. It's not the plus sign. It's a minus sign. And you can always double check yourself real quick. I'll use the green marker. You see what happens when I multiply those two together and distribute? I get the negative 2x. When I distribute back, a negative 2 and a negative 2 gives me the plus 4. And as I look at this next step now and say, well, is it correct that, look, I did get, again, a parenthesis that's identical. Therefore, it is the greatest common factor. It comes out in front, and what's left over goes in its own parenthesis, 3x minus 2. So the rule on this one is if the minus sign exists between the terms instead of the plus sign, then what we'll do is pull the minus out as part of the GCF. Now, if we look at question D, yeah, there's a rule down there. Let's see if we can make sense out of it after we try to attack it. So I've got 10x squared and 15x. So if I want to factor something out of those first two, 5 comes out and then x comes out. I open up a parenthesis. So I took the 5 out of the 10, that gives me 2, and I have an x left. Okay. Bring the plus sign straight down, and I took a 5 out of the 5x out of the 15x, leaves me 3. Okay, well, I don't have that negative. That's nice. I bring that down. And now you're going to say, okay, let's see, what could I pull out of 2x plus 3? You're going to say, that thing doesn't factor. I must have done something wrong. No. Look at the rule now. If there is no other GCF besides a number, then the GCF automatically becomes 1. So therefore, we assume, and it is not just a silly assumption, we can pull a 1 out of every single number in the whole world. So we actually don't usually care about doing that. But when we have nothing else, we like to show the 1. Okay? And now we can continue with saying, oh yeah, there's my 2x minus 3. He's a GCF. He comes out of both. And my leftover is the 5x plus 1. Okay. If I don't put the 1 there, I'm going to have something silly that looks like that. And you know that everything we've had so far always has 2 things inside the parenthesis. So it's 5x plus 1. Okay, now the grouping method is practice for actually showing you how to factor when there are 3 terms and the a is not equal to 1. Let's look at that in the next page. So on the next page, you see an expression that we're going to want to factor. 2x squared plus 5x minus 3, right down here. Now, if I asked you to factor x squared minus 4x minus 5, you would not need this method called split the middles, or the ACB method, or sometimes called factor by grouping. Okay? Because when we see something like x squared minus 4x minus 5, I see that the a is equal to 1. And I go right to my double parentheses like we did in the previous sections and say, oh, okay, well, it's got to multiply to be 5, 5 and 1. And it's got to add to be negative 4, add to be negative 4. So I need a negative on the 5 and a positive on the 1, and I'm all done. However, our problem doesn't have an a equal to 1. So let's talk about how we factor 3-term expressions, right? Trinomials, because this one at the top that I gave you is 3 terms, just the a is equal to 1. Here we have 3 terms, and the a is not equal to 1. Oh, so we go back to doing what we've been doing for the last couple chapters, identifying what the a, b, and c are. A is equal to 2, b is equal to 5, and c is equal to negative 3. Now, it's asking us to find the multiplication of a times c. So when I multiply a, 2, times c, negative 3, I come up with negative 6. And I want to put that number right down over here. That AC, a times c, is equal to negative 6. In fact, I rather just write it over here, okay? A times c is equal to negative 6. Now it says, look at b. Okay, well, let me get the pen going here. We'll do blue. So I want to know what b is. Well, b is equal to 5. And I'm going to put that b right over here. You can see why this method is sometimes called the ACB method. Look at them right next to each other. Keeping in mind now, A times C, those numbers are multiplied together, right? The B term is usually, look, I'm circling that 5 in the original problem. Remember, it's always got to add to be the middle term. So I'm going to write the word add. So instead of just multiplying to be the back term, like we do when A is equal to 1, we actually multiply the A and the C together and say it's got to multiply to be 6, and my number's got to add to be positive 5. Okay. So what I have to do is think about what's the right combination for that to happen. So let's go with 6. We know it's 6 times 1 or 2 times 3. That's the only way I can make 6, right? Now, it's got to multiply to be negative. That means 1's got to be positive and 1's got to be negative. And in the end, it's got to add to be a positive. That means the plus sign goes on the big number. So therefore, if I had a plus over here and a minus over here, or if I had a plus over here and a minus over here, this one is the one that gives me the plus 5. This one gives me plus 1. So I need to remember that the right combination is plus 6 and minus 1. I'm going to erase for a second the fact that you remember that it was really multiplication between those guys. Now, it says, so we found the factors, okay, that, and they are plus 6 and minus 1. And now watch what we do. Here's where we split the middles. It says rewrite the original expression. So here it is. I'm going to bring it down over here. Now watch the way I'm going to rewrite it. I'm going to rewrite the first term. I'm going to leave some space. And I'm going to write the back term here. So, oh, that's not good. Let me make that look a little better. I don't want it to go here. I want to make sure that we're using pulling the first term. So we pull the first term, we pull the last term, and in here is the middles. Except we now realize that that plus 5x, I'm not going to bring that down. I'm going to replace the middle terms with a plus 6 and a minus 1. Because remember, they form the 5, but they're really minus 1x and plus 6x. That's how I get the plus 5x. And I'm going to pick that up right there, and I'm going to bring it over here so that I have minus, and I'm going to keep the 1 there, 1x plus 6x. And you can see that's the blue 5x that I had in the middle. That's why we call it split the middles. And sometimes we call it ACB. And you can see how we get the middles by using ACB. So now look, we just created 4 terms. And we should be experts based on the page we just finished prior to this. That I'm going to group the first 2 together, and I'm going to group the last 2 together, and I'm going to see what comes out of there. Now, it tells you, okay, put a big fat plus sign between them. So it really wants to push that there's a plus sign between them. I'm going to rewrite it. And I'll do that big fat plus sign like they ask. Okay? And now we're going to group the first 2 together. Okay? when we group the first two together, let's change color. Let's go back to green. When I group the first two together, all I could pull out is an x. When I'm done pulling the x out, what do I have left? 2x minus, well, I pulled the x out of the back term, all I have left is 1. And we'll keep that plus sign in between. And now I'm going to group and factor the back two together, just like I kind of grouped and factored the first two together. And now I'm going to pull out between 6 and 3. The best I could pull out is a 3. And what's left over? Well, based on the previous page, it better be the same darn parenthesis that I have over there, 2x minus 1, and it is. Pull the 3 out of 6x, you got 2x. Pull the 3 out of the 3, don't say there's 0, it's 1. And now, one last time, it says factor out the GCF from each group. We know what that means. That means that GCF of parenthesis of 2x minus 1 comes out in front, and we open the back parenthesis for the leftovers. I'll do the leftovers in red, so let's look where they are. They're in front of that parenthesis, and they give me x plus 3. And it says write your expression in factored form. We have it. 2x minus 3, x plus 3. Okay, as we turn the page, well, let's look at 2x squared minus 7x plus 3. So we're going to use our ACB method because, again, the a is not 1. If it was, we could use the other method that we learned in the previous section. So a is equal to 2, b is equal to negative 7, and c is equal to positive 6. So let's do that a times c, and I'm going to kind of put it over here where I have room. So a times c turns out to be positive 12. Okay. I put the positive there because I got to remember it's got to multiply to be positive. And let's grab the b and put it right next to it. ACB, and the b is negative 7. So remembering again what that AC was, a multiplication, so it's got to multiply to be 12 and it's got to add to be 7. And it's got to multiply to be positive 12. Well, that can't be two plus signs because I got a negative, but it will be two negative signs. So I don't know, I got 1 times 12, I got 2 times 6, and I got 3 times 4, and those guys are going to be negative. So now I listed them all, right? And now I got to pick the one that's going to give me the negative 7 that I'm going for. And here it is right here. Negative 3 and negative 4. So it's really negative 3x and negative 4x to make the original, way up at the top of the screen there, I'm circling that 7x. You see where it came from. I just split the middle. Okay. Now I want to rewrite that expression and split the middle. So remember, I always grab the first term. I grab the last term. I leave a little room in between. Okay. And now I put that middle term, negative 7x, down in between. And actually, I have them right here. So I'm just going to drop them right in there now. Negative 3x minus 4x. Okay. And it says to put a plus sign in between there. I'm not sure I really want to do that this time. It's okay if I tried to squish a little plus sign in between. I'm not sure what we gain because plus negative is kind of so silly. We're getting to be pretty sophisticated with our math. We don't need to see a plus and a negative right next to each other. So let's finish this. We realize now that we have two groups. I'm going to grab the first two and factor out what I can. Well, all I can pull out is an x. And I'm left with 2x minus 3. You remember from our first page of this video that we said whenever there is a negative sign, we pull that negative out with, it's part of the greatest common factor. And between 4 and 6, the best I could do is pull a 2 out. And I'll open up a parentheses for the leftovers. And when I do that, I have 2x minus, now remember, whoops, I'll check that. I pulled a minus 2 out of minus 6. All right, I'm going to do the typical student mistake. Bring the minus down and go 3. Okay. And why is that a mistake? It's not a mistake. This is a plus 6. I forgot to copy that correctly. The original question, if we look at the top of the page, has a plus 6. So that's my bad. So let's change it right there. That's a plus. That's a copy it down. Wrong arrow, right? I said let's grab that 6, and there's my arrow coming all the way down. You can see me writing it again, and I forgot the plus sign in front of it. So actually this works out good because we double check. When I pull that negative 2 out of both terms, I need a negative 2 to multiply to be negative 3 to give me the positive 6. And yes, thank goodness it works because I see that those parentheses are identical. I pull them out as the greatest common factor, open up the new parenthesis for the leftovers, and we'll do some yellow. Let's see what's left. X minus 2. Oh, that doesn't look so good. We'll change it. And therefore I factored that completely. So my expression is 2x minus 3 times x minus 2. Okay, now you can go to some of the other problems that are there. In the section, we have some problems that you can try that are already worked out, okay, already worked out, but make sure you can work them out using this video to help you. Okay, see you next time.